Hi there. So I wouldn't normally do this kind of thing. This is a bit uncustomary for me, but I spent quite a lot of effort today fixing three Jinty class engines for my 7-year-old. We got a couple of non-runners from eBay and from the fantastic Great Eastern Model shop here in Norwich. I was just going to let the video roll and basically just explain itself, but there was quite a lot of effort involved and there's quite a lot of intricacies in the process. So what I thought I'd do, you lucky people, is narrate over the top. You'll be glad to know I am releasing a video without the narration too, just so you can get the hashtag ASMR aspects of it all. So without further ado, what I did is took these three lovely Jinty class models, which were in various states of disrepair, none of them particularly running, as you'll see, and did full rebuilds really of their motors. Now, it is possible to go slightly deeper into a rebuild of a motor and doing windings as well, which has been done in the past, but in this particular case that wasn't necessary, although you will see that one of them did need probably a little bit more work than I've done to it. So enjoy.
Yeah.
Okay, let's see what it does. So does it run or not?
I would have liked it to go as fast as this one. Oh no, I forgot it didn't run.
Sounds like a half runner. That sounds like a brush problem. How much fixing has it had?
We've only fixed it once. It was from the scrap pile, not in a model shop, in another model shop.
Oh yeah.
I got it with Mum. So it's in another scrap.
Has it been remagnetized? It sounds like it has.
We could clean it off inside. It hasn't been. I was 5 when we got that one.
Oh really? It's been a long time since it's had any particular... That's not bad, Ed. It's
That's what keeps happening. It keeps stopping. Like that.
sounds like a brush problem. Okay. It's a brush problem on the wheels, isn't it? Let's have a...
So this is the first Jinty that we were fixing. As you could tell, we were trying to diagnose the fault. The first issue was I was thinking maybe it's just a simple brush problem with the pickups from the main wheels, because it just kept on just stopping randomly. Either way, the process you can see is to take the cover off, remove the brushes straight away, and just using some baby wipe basically and a fiberglass pencil, just cleaning the commutators of the motor here. You can see also you definitely need to use a little knife in between the poles of the commutator just to prevent shorting out. I thought I'd put the brushes straight back in again and see. But then when we went to test it, it still was causing problems. There wasn't really that much going on. So take the bottom off and have a look at the pickups too, which were probably in need of a bit of TLC. Unfortunately, when you remove the base plate of any of these trying engines, there's actually not that much space for the brown wire that connects the pickups to the motor. So you actually have to take the motor out. I would just take the opportunity to clean some screws, because they're the grounding screws, and clean a bit of the grounding plates for the motor too, just so that the ground can work properly. But when you do it, it allows you to then free up that brown wire. Off screen, I'm just trying to sort of clean up some various bits and shine some various parts here as well. What you see here is just going over the wheels, getting rid of any old grease, just with a baby wipe again. And now just a bit of emery paper as well, just on the pickup, the contact surfaces of each of the wheel, just go round one time. And now just desoldering the pickups themselves from the brown wire, just to allow us a little bit of access, better access there, without having to potentially break the pickup by a little bit of overzealous emery papering. there's only really two wheels that have a have the pickup on, so that's all you need to do. There's no point doing anything else. And then with a fiberglass pencil, just take away any of the extra sort of extraneous bits. And then you just see resoldering the pickups back on, screwing it back into the bottom. In some of the engines there is the original piece of paper that was separating the base plate there from the actual chassis of the engine. In this case it didn't seem to be needed. There's indentations out of the metalwork just to stop them snagging on each other and shorting out. Just run it in a little bit there on the mat, hopefully plug it back in and then put the motor in. No job's ever as simple as it seems. So unsurprisingly it wasn't running. Next step really is to get the voltmeter out just to double check. I'm having a bit of issues with my controller. The wire, believe it or not, is a bit dodgy, as you can tell, so you can see the voltage going between nothing to 14 volts depending on the wire position, so obviously worth just making sure that was connecting okay. Now we see it was running now. Always get the opportunity when the engine's running to actually just polish up the wheels a little bit, make those contact surfaces a bit better. A bit of emery paper first of all, and then a fiberglass pencil again. Make them shiny-ish. There's no real need to get them perfect, but certainly better than they were. Unfortunately, the connecting rod decided to fall off at that very point, so that was a case of cleaning that up and putting it back in again. I see it's running quite well. Now the next stage of the problem was, as soon as you put the chassis back on, a lot of the time moving around in the wiring is a very, very close tolerance inside the shell. And you can see I was just pushing the brushes to make them rear in a bit. As soon as you put the shell on some of these engines, as soon as you've had them apart, of course it pushes the wires down, and then the wires push the brushes out the way. So it's just a case of iterative steps now to just take it off, push it back again, take it off, push it back again, move the wires around a little bit so they're not snagging. In this case I had to bend one of the pickup, one of the brush connectors just out the way as well. Give it a bit of more of a clean too. Unsurprisingly, most of these jobs require taking things apart. At this point you just see me remagnetizing the motor because I thought, well, why not? I've already taken the thing apart again. Clean up some of the contact surfaces just in case there's a grounding fault. I write the N with an arrow down there just to give myself a reference to where it's meant to be. Clean up some of the springs too. Obviously one part of the spring is insulated, the other part of it is not, such that the case is continuous with the left hand pickup and the red wire is continuous with the right hand brush, not pickup. Put it back on again. There we go. Intermittent fault once more. And that's just a case of fiddling around and bending things so that they don't snag on the case when you put it in. At this point we've managed full success. It's absolutely fine with the case now. And she runs absolutely fine. That was the first of the Jintys, 47606. Another identical sister ship is yet to come.
Let me just film it going slowly and then we can talk again. Let me finish. Let me do this too, and then you can work on these commutators, okay? I don't want to do it too hard, obviously, because I don't want to break the...
We might need to remagnetize.
Oh, definitely.
So you join us for video 2, or train 2, should I say. I'd already started it actually by the time I started the recording. If I'm honest, this was the second one of the two, but the first one made more sense to view first. We'd already decided to take it apart because it was a completely non-running engine. In fact, looking up inside it, it was absolutely gunked up beyond belief. There was no way any of those parts were going to be moving. As soon as you put it on the track, it basically shorted out. So what you got is Eddie over there on the right hand side, just doing some fiberglass penciling on the brushes, and myself there using some methylated spirits on anything that was a bit greasy, just to clean them up a bit with a bit of toothbrush and eventually fiberglass pencil. Yeah, I'm just doing the contact surfaces of the X04 motor and preparing it basically for a bit of remagnetizing. Sorry about the angle, I just zoomed in on that image there. So that was a soldering iron just to get the initial brush contact desoldered from its wire and made shiny again as well. That's the red wire brush that goes on the right hand side. I say red wire and chassis because, to be honest, I can't remember which one's negative and which one's positive. It sort of depends on what the polarity of your track is anyway. No time like the present to use a bit of fiberglass pencil on the connecting rods, make them look a bit shiny as well. And again here, polishing the contact surfaces. The capacitor had actually fallen off of this little clip here, which wasn't really causing any big issues, but I don't like things floating around that aren't connected well, so I thought I'd just tin it up and put a little bit of blob of solder and just reflow that solder joint so that it didn't fall off in future. The red wire actually had snapped at the join, so instead of trying to faff around with a too small piece of wire, I thought I'd just get another piece of red wire and re-tin the end and use it from scratch. So that's what you can see happening here. And putting that back on at the join between the capacitor and the pickup. The capacitor is really just there to stop sort of arcing and sparking, causing interference with what would have been analog televisions and radios back in the day. Digital stuff is a lot less bothered by high bandwidth interference like that, but it's always polite to the neighbours. Just putting the spring back on now. And again, giving it a bit of a polish with a fiberglass pencil. Pencil. And cleaning up the connecting surfaces for the brushes too. I always say make sure we don't sand down the brushes themselves. Obviously, it's always worth even marking one of them just to see which side it was from. I always make sure that I put a dot on one of the brushes before I take them out, because they've had years and years to wear in, so why undo wearing in? You just saw the oiler there on the oil pads. You hear the engine just squeaking there, so it was definitely needing a little bit more. But it needed a bit more work than just that at this point here. You can see it trying to spin. It just wasn't quite perfect at this point. So here's just using the oiler and the fiberglass pencil just to fix up the pickups and the brushes for them on the inside wheels there. Just undoing the bottom of the engine as well, and just clean off the connecting surfaces to the pickups from those wheels. And a little tiny oil spout that I bought from Great Eastern Models yesterday, just to get in the tiny axles there and just provide them a little bit of lubrication as well. And use a bit of emery paper again on the inside surfaces of those wheels near the pickups, so that just adds to that electrical conductivity. And polish up your bolts, why not? Again, just running the wheels round just to give the contact surface of the wheels a bit of a shine as well. Anything that looks shiny generally picks up electricity quite well. Of course, the risk is after a while it oxidizes, but my hands were so greasy anyway, I figured that would probably give enough of a sheen of grease. The bolt that comes out of that, or the screw, sorry, that comes out the back of the motor there is actually one of the connections between the motor and the chassis, which again is one of the rails, so it's worth having that nice and shiny and working too. Just put it on the rolling road and trying to start the motor, and it just kept on stalling at this point. Out come the brushes again, give them a bit more of a clean. And try and sort the wiring out inside as well, so they're not going to snug on the chassis later. Of course they will do. Most fiddly thing is trying to get the brushes in and out. We managed to get some semblance of success out of that engine there. And as time goes on, you could hear it just pick up speed. I wasn't adjusting the controller at all, it was just letting those brushes wear in, or bed in really, and now getting the opportunity while the wheels are spinning to just use a bit of emery cloth on the wheels to shine them up, and the fiberglass pencil to finish. Just a demonstration really, she's perfectly capable of going fast and going slow. Good crawler. Definitely got all three coils working on this engine.
So you can screw something through that one's funnel if you want, and you can screw something through the side of this one if you want.
Oh, I see. Down, fit down.
Because they can be screwed in whichever.
Just noticed the red wire is quite high up actually, and that was a problem later on when I'm trying to put the case back on. As you'll see now, every time you try and put the case on, it snags. So it's a case of just bending a few of the contacts and hoping that you don't undo all your hard work. Sort of looking inside the case going, where on earth can that snag? Why is that stopping it from working? But of course, you know, even pushing that wire a millimetre when those brushes are only just sprung in anyway can be the difference between contact and no contact. So it's just making sure that things are bent out of the way of the case so the case can't push against it. Finally working, put the screws back in, fighting with those case screws, and the job done. Okay. Most of it's quite new, isn't it? It looks quite nice.
But it didn't work.
What's that? Oh, that's off. Okay.
Why is that changing?
It's a bit sluggish, isn't it? And it stops. Backwards, nothing. Okay. It's a little shorter this side. So this is the third locomotive, the third Jinty. This is the GN&SR. I think it's Great Northern and Southern Railway theme from the Railway Children book, so not a true locomotive, but still a Jinty 060 tank. This was actually the most challenging of the three. It didn't finish in the best possible condition that I wanted it in, just because of timing. You'll notice here that I was taking out the puffer, really, the smoker. So what the problem was on this engine is it kept on shorting out. Every time you put it on the rails, it just shorted out. So I know for a fact that we're never going to use the puffer, so I thought, well, the problem with it is it takes two things away from the engine. Number one is of course the engine has to share its voltage with the heater coil, and the second thing is the piston inside it actually adds drag from the X04 motor when it's trying to drive. So, you know, not just stealing power but also stealing drive, and then by nature stealing power again, so it's just not ideal. You just saw the Sharpie there, that was just marking the side of the motor and the brush on that side. So at this point I'd taken out the piston from the smoke box and just popped it aside and disconnected its main power wire as well. Eddie'd been out there cleaning up a few things with some methylated spirits, trying to ask him to do it very gently because the risk of taking out a wire on the commutator is pretty high and they're very fiddly to try and fix. That's just taking out the base screw, marking north on the motor as well, on the magnet of the motor. So I was just taking opportunity there to oil the bearings while Eddie was cleaning up the motor for me, making sure they're all seated nicely and spinning okay, and then giving the brushes a clean. You see the brown wire there connected to the pickups, the brush pickups, resoldered in pretty nicely. If you don't unsolder it when you take it out, you run the risk of just snapping the thing, so might as well do it properly. And just screw the base back in again. So Eddie over on the right hand side is just using some methylated spirits and a fiberglass pencil just to try and clean those commutators. Unfortunately, the brush spacer, the little holder for the brush, was very brittle and snapped. This is what this engine turned into quite a complicated task for me, unfortunately, but we thought we might as well just keep fixing the rest while we could. I asked Eddie to just clean the contact surfaces of the engine while he could, and that was what he was doing as well, just to allow the grounding to work better. Make sure that was clean. Break for lunch in a second. There he goes. It's a dab hand with a fiberglass pencil. And the second of the two brush spacers now fell out, so never mind. Certainly wasn't his fault. It was they're just very weak, and they'd been exposed to oil for about 40 years, I should expect. So just brittle, really. Put aside. And right, that's me now. So looking at the engine, sorry, the motor, trying to figure out how to fix this. Part of the job was to then get an old X04 motor that's currently lacking, I think it's just lacking a spring actually, and measure up its spacer, or whatever you want to call it, the brush holder, using a micrometer or a vernier caliper, sorry, and one of these exciting LCD write-on displays that you can get for about £3 in Aldi. They're fantastic for making notes on. So I was just measuring up here to try and figure out the dimensions. And the best engineering drawing I could manage. Don't I write fast? The brushes themselves need to be that far apart. That's how far apart those holes were. So I didn't try to measure the distance of the holes. I just measured the distance, measured the size of the piece of metal that they went round. The width is also quite important because it allows the brushes to be centered on the commutators, and the size of the holes is actually important, of course, because that's the size of the brushes. The outer diameter is relatively important as well. The outer dimension is because obviously that dictates how far the brushes are apart. There's a little bit of leeway with those because they're sprung. The actual depth of the material, relatively important, but I knew I had roughly the right stuff. I didn't even bother measuring that when I was using the variboard later on, as you'll see. I was just trying to work out the dimensions of the inner hole. I had to revise my idea of having a hole in there later because the rivet in the actual motor chassis was a bit stubborn, and I thought there was a better way to do it in the end, so you'll see that later. Now over to the garage. I found this tiny little strip of variboard, which is exactly the right width for the job, and that was from a very old electronic set from the 70s. Marking out on there was a bit of a challenge. I had to use the verniers just to scrape. I'm not a particular fan of doing so because obviously they're blunting a nice precision instrument, but frankly on plastic board it wasn't a disaster. The reason I couldn't just 3D print something for this is because it's a relatively high temperature environment with the brushes, so you have to use a thermally resistant material, otherwise it fails. So scrape markings, all to the right thing, and files are fantastic at marking out on things as well. So I spent a while trying to figure out how to get a 1.5mm drill into a Dremel with a collet of 2.5mm, and gave up and decided to use a pillar drill instead. But I saved you the excitement of having to see that bit and skipped ahead. It's just a case of drilling those holes in the right places, one on each end of the part that requires the freedom for the brushes to go in, and a bit of up and down work just to just to basically do the equivalent of a poor man's milling. I do not own a milling machine. I will own a milling machine. Just a rectangular file now, just to make those holes the right widths. You might have just seen the shininess of the contact at the bottom of that board. I had anticipated them-ish and broke the contact between left and right, thinking that was enough to stop the contacts from short-circuiting the brushes, but that did bite me a bit later on. So back into there just to drill the central hole, thinking that was the only solution to the problem. Of course it wasn't. Sorry for the wire in the way here, it was dangling from the roof of the garage. And now just filing and hacking it into the right shape. And that was just removing that central contact from the Vera board, from the PCB. That was now thinking, okay, how am I going to mount this thing on here? That rivet was a little bit stubborn, pretty strong actually, and I thought initially I was just going to put it in, and I thought, well, I'm just going to saw down to the middle, allow a little gully, just slide it over the top of the rivet, and that's basically what happened with a little bit of jiggery pokery. Sorry for the washing machine in the background, having an exciting time on its spin cycle. I just took a few attempts just bending that rivet slightly and filing away at the entrance before I could just finally squeeze that board on, and it's just a friction fit really, there's nothing else holding it in place. It was a bugger to get off, so I think the chances of it actually falling off during normal use is pretty slim, or at least I'm hoping that, and heck if it does, it's very easy to fit and put a bit of super glue on it. The reason those little PCB traces bit me was because whilst I separated the two left and right, what I didn't anticipate, of course, is the fact that the motor housing made of metal would actually bridge that gap that I'd made, and subsequently short-circuited it anyway. You'll find that out later, possibly within 3 frames. Here's a remagnetizer, just a quick zap in there just for the motor, and she's good as new. If you can pick up the motor with a screwdriver, she's probably magnetic enough. Just cleaning those contact surfaces where the brushes are going to sit, the spring's going to sit, and where the motor sits on the chassis, and clean the bottom of the screw because that's what contacts the actual spring itself, which delivers half of the power to the brushes. That's that in now, so the spring's in, and it's just a case of fitting the brushes into there. Bit of a tidy up. Bit of methylated spirits just to tidy up those brushes as well. Obviously didn't quite get the gauge right, the gauging right, so I had to just file those holes down just a little bit more. I didn't want to do it too much in the garage in case I was a bit overzealous, so just using the edge of the file, make sure that the brushes can fit in there. Which they eventually did, including the contact brush too. The one attached to the red wire just needed a bit of a clean, so that got a bit of a polish with the fiberglass pencil. As did the rear contact just at the bottom of the capacitor as well. And just screw that in nice and tight. Had a bit of an issue trying to get that particular brush into the hole that I'd made, so unsurprisingly redid the hole just slightly. Actually took the brush off its solder and put it on the other way around. Now I think the original Triang design is for that contact to actually be on the outside face of the brush and the outside part of the clip. And fine, but I just, with the way that was set up, it was actually a bit of a faff to do that, so I did it the other way around. It's always surprising when you open these things up to see how many adaptations and changes people have made over the years. So I was having a problem here, and I didn't know what it was. I eventually went on to continuity mode, and every single time I turned the wheel, you can hear it beeping continuity, so short circuit. Of course, at this point I was thinking it's probably something stuck in the commutators, and went all in trying to, there we go, using a knife in the commutators, blowing it all out, trying to figure out what was going on. And only then, a little bit later, did I realise that it was actually that PCB trace that was causing the problem. At this point I was thinking, why is it still shorting when I do that? Because it was taking it completely away from the case, and it wasn't shorting when I was just applying power to... Well, in fact, let's have a look. So it wasn't shorting there. But every time you apply power, you just see the LED go out on the controller, so there's definitely a short going on. So it took the motor back out. I think it was probably around about this point that I thought, bugger, it's obviously that trace that I thought I'd got rid of. I also took the opportunity to measure the resistance of the coils by each of the neighbouring commutators, and I actually did find that the motor itself does have a loose connection to one of the coils. With a bit more time, effort and energy, it is possible to go in and so you can see the voltmeter there doing its thing. It's possible to go in and actually resolder the connection between the coil pickups, the neighbouring wires, but it is a complete faff, and the chance of breaking it further is a lot higher than the chance of it just working with a bit of an error. So here I was just reflowing the solder on the commutators. Obviously you can't see that because my head's in the way. But it made absolutely no difference to the resistance values, as you might see just quickly. They're meant to be about 11 ohms. Each one was 11 except for one pair which was 22, so obviously a problem there. It's actually meant to be a bit less than 11, because if you think about it, as a resistance network, if all three are connected, it'll be actually around about the sort of the 8-9 ohm mark. So I thought, well, at least we got some resistance between each of the pickups, so stick the brushes back in. That was me filing the backs down so that they didn't short circuit, and put them all back together again. I put the file into the motor just to allow the rivet to stay up so I can just squeeze the board on. It's quite a snug fit, so the chance of it falling off is pretty slim, I hope. Famous last words. And there we go, one motor running absolutely fine. Give it a bit of a clean with some meths and a toothbrush on the worm gear, and put it back into the engine, the locomotive. Yeah, she works fine on there. Just an opportunity to oil the pads. And of course never works when you put the case back on. Just fiddled around the wires a little bit inside, and actually it was okay. About a 5.5-year job trying to get the screw back in the case, but finally managed that as well. And we got one working fake Jinty. So there you have it. Rapid restoration of 3 Jintys. Made it look easy, right? Each of these videos, which is what, about 10-15 minutes long, in reality took around about an hour to an hour and a half each time. Obviously the GN&SR train took a heck of a lot longer because of trying to make that new part out of the PCB. But if that hadn't been the case, it would have still been a good... that's about an hour to restore an engine like that. You can hear it chugging a little bit, and actually that is pretty... yeah, it's difficult. Give it a bit more time. I would quite like to go back into it, try and reflow the soldering joint between the two coils, the neighbouring coils that are obviously not working. But frankly, it works well, and the boys enjoy it. So, thanks very much for watching. Hopefully, we might do some more of these as well, just a bit more detail in various parts. Thanks.